Hello everyone, welcome back. Hope you are following along with the steps and practicals that we are doing. In previous session, we performed Docker build operations by writing Docker file and then converting Docker file into Docker or container image, and then we pushed the Docker image or container image, whatever you want to call, into Docker Hub repositories. That means we performed Docker dev side of operations in previous lab. In this lab, we are going to perform Docker run operations by using prod node that we had created during our lab setup, and we are going to perform run operations and pull operations to run the Docker images as a container on top of the Docker daemon that we have created. So let's jump onto our one virtual box and turn on the prod node that we had created. So my prod system is running. Now let's go and find the IP address so that we can access it outside the virtual box. I will use the same username that we have created here, is demo. This is having IP address of 192.168.56.105. So we'll go there and we'll use our prod node. We'll save it for later. Here we are. I'll minimize this virtual box image, virtual box application, and this live image also. I'll increase the font a little so that we can see what all the changes I'm making, what all the commands I'm executing. Here we are. So now what I'll do is, first of all, I'll execute docker image ls command, which is going to fail, of course, because my Docker and container services are not running on the system because we just turned it on. So as a default practice, we should always turn on restart or start the services which is related to Docker and containerd before performing any Docker command, functional command and execution. We will use systemctl start Docker and containerd command to start the services. It is asking for the password, authentication required. Okay, I did not use sudo, that's why it has failed. Now let's validate the status of the service that we started to make sure the services are running. Yes, of course, the services are running. Now what I'll do is, we'll perform two commands here, docker image ls to make sure that there is no container image locally stored on the system, and I will also perform docker container ls to show that is no container running on the system. So these are the two commands that we use to validate, that we use to list the number of containers and number of images that are running, that are locally stored or running on the system. So as we can see, there is no image, nothing is running on the system. So what we are going to do is, first of all, we will perform pull operation to pull the images, because we use pull operation to pull the images. Those are stored in the Docker Hub repository, and then we use it to locally download it. What we are going to do is, we will perform, but before that, let's go to our Docker Hub repositories to find the path and the name of the files that we want to download here using pull operation. It will ask me to sign in, of course, because I am logging it after a long time. Yeah, cool. So this is my repo name, and if I go inside this, I'll find the image. What I'll do is, I'll download one of these images. Let's say I'll start with the Ubuntu system image. I'll click on it, then it will show me the path to download it. We can use this and we can run a command which is called docker pull and followed by the path. This command is again going to fail. I'll tell you why. As you can see, error response which is saying pull access denied from docker demo all. This is the path and repo name, and repository does not exist or may require docker login, of course. The reason is, you remember, right, we created the repository that we created is type private. You can see here. So that means without login, no one can access it. just because I have not yet logged in using my prod node, I'm not able to access the repository. Let's do one thing. Let's also change the host name, system name of this Docker node for better identification. The same command that we need to use, sudo host name ctl followed by set host name and then name that we want to give. Let's say we want to give prod node. Now host name is changed. Now in order to make it effective, I'll immediately run bash command. Yeah, here we are. So we are on prod node. Now what we did is we have not yet logged in into a Docker Hub repository. That's why we are not able to pull the image. So there are two ways to solve this problem. The idle way is, just because repository is private, we need to log in into the Docker node, this our prod node that we have created here, using the credentials that we have created for Docker Hub repositories, or we can access it, or we can make it public to access without login. So as I said, whatever confidential or proprietary images or information that you are keeping in your repository, make sure you should always keep in private repository. Now just because I kept in private repository, I am not able to access it from outside without authentication. This is applicable for everyone. No one can access my repository, no one can access my images or the container, all the things or objects that are created or hosted in my Docker Hub private repository. Let me show you the difference first. I will go to our repository, then the repositories will be listed here. We need to go to settings, and in the settings here it is saying make public. That means after making it public, I will not require my login and password to be defined or to be like given or entered in this particular node that we are created. Let's quickly do it. I'll convert this to public. It is very simple. We need to give the Docker name, the exactly file name, that is our repository name. Okay, now so as you can see, it became public now, and it is giving me an option to convert it into private whenever it is needed. So just because I'm not having any sensitive information, it is very generic image, I can convert it into public for your demo only. You are advised not to do this if you are having any critical sensitive information or repositories or images in your registry, Docker Hub registry, or any public registry that you are creating. So now I'll perform the same command. Let me show you Docker image ls to make sure nothing is there, and I'll perform the same command that the command was this. Without making any change, I'm going to perform exactly same command, and this time it is not going to fail. It will be able to find this repository because it is public now, and it will download the images that we have created or that we are going to pull it. It will take some time because of the image size, and it also depends on the internet space that you have. So I'll pause the video and come back once this downloading or pull operations is complete. As you can notice, just like it sliced the entire image into multiple smaller sizes while uploading or pushing the images to Docker Hub repositories. Similarly, while downloading also, it has divided the image into multiple slices so that it can perform parallel downloading through multiple threads to speed up the overall downloading experience. That's why we are saying, just however we are downloading only single image, but still we can see multiple downloads are happening here because it has created multiple chunks, multiple slices of the same image. Once that is done, we will be able to see that the image download is complete. You can see, right, pull complete now. One slice is completed, second is completed, third is also completed, and that's all. So all the complete image has been downloaded. So you might have remembered, right, I had explained when I was explaining the demos that if I am going to perform Docker run operation, Docker run operation is used to give an instruction to Docker daemon that whatever image name is provided or is passed through the Docker run operation command, look for that image. If it is locally stored, use it and run as a container on top of the Docker daemon platform that you have. If it is not locally stored, then initiate a Docker pull operation on behalf of the docker run operations automatically, and then go and find the docker hub, go and find that particular image from the docker hub registry and pull it and then run the container. So there are two types of pull operations. One is proactive pull that we just did, and the other one is reactive pull. So reactive pull is basically it is automatically executed or performed on behalf of the docker run command which was executed, because the image is not locally stored. So that's why, to show you the difference between the proactive pull and the reactive pull, that's why I pulled this image in advance. So this time if we will create a container using this particular image, whatever image we just pulled, it is not going to perform docker pull operation. Rather it will look in locally and it will find the image and then it will run the container. Let's go and perform the run operation and see the impact now. Now let's perform docker image ls command to see what all the images are locally stored. You can see the image that we have downloaded or pulled from the docker hub repository is stored locally in my system now. You can see all the details related to the image, which is a repository name, tag, image id, creation timestamp, and the size. Now what we are going to do is we will perform docker run operation. Command is very simple. We need to use docker run followed by the name that we need to give, an hyphen name. Let's say we want to give it Ubuntu sys1, and then we need to use -d, which is basically saying run in the background so that there should not be any disruptions when I am terminating the terminal, and then -p, which is indicating publish the port, and then I need to define some port number here. I will know the difference why I'm defining this port in our network section, but here let's say this is the command that we are going to use to create or to run a container using the image that we have created. What we are going to use, we'll use this as an image repository and this as a tag, and this is the format that you need to use. What we are doing is we are running docker command, performing docker run operation. There is a typo here, and then hyphen name, defining the name of the container that is going to run, then -d, that means run it on the background on the daemon, then -p, that means publish the port, and this is the port that we have defined. This is the port that is being listened on the container, and then this is the repository name colon the tag which is associated with the image that we want to run. That's all. We can enter the command and you can see the container got created. We got the container ID, which is randomly generated, which is an alphanumeric character or number or value that gives a unique identification to all the containers that are running on the system. Now let's go and perform docker container ls to see what all the containers are running here. Yes, so the container is running now. What we can see, we got all the details of the containers that we just created or launched using the container image that we had downloaded from the repository. We can see the container ID, name, tag, commands that we had defined in our docker file, creation time which is 21 seconds ago, uptime it is saying, and then the port that is published and the name, of course. What we are going to do is, before creating the second container of our second image, that websys that we had created, I'll convert this repository back to private so that we can see the difference of public and private. I'll make it private again. I need to define the repository name again. So it got converted to private, and what I'll do is, let's go and find the name of the image first. However, I know, but it is if you don't know, you can use this particular, you can go to your repository, browse it, the image, locate the image, and then you can use this command. You can see, right, command is mentioned here. You can use it. Just copy from here, paste it, and replace provide. So this will remain. So docker push or not push, exactly we are going to perform pull, but this time we are not going to perform pull operation proactively. However, I'll show you. just to differentiate, we are going to perform pull and then the image name, which is tag, defined here. Remove the tag, add the actual tag and enter. The command is going to fail because we converted our repository back to private. That's why access denied we are getting. This time I'll execute docker run command directly without pulling the image from Docker Hub repository proactively to see how it is going to identify that the image is not locally stored, and then it is going to make decision to invoke a docker pull operation on behalf of docker run operation that was executed by the docker admin or DevOps or SRE, whatever you want to call, you can call it. And then after pulling it, it is going to create the containers, of course. So let's do it, but before that, let's log in into this. This one, the command is docker login again. Docker login. It will ask for the username or repository name. I'll copy from here, paste it here, then the password. Yeah, so login succeed. What I'll do is we will run docker image ls command once again to show you what all the images are there. You can see only one image, that we pulled using docker pull operation initially. Now we are going to perform docker run command directly for the websys. We'll use the exactly same command that we have used for this. We'll just simply change the name. We are calling it websys again, websys, and the image name also websys1, websys1. So again the same command, we just change the container name and the docker image tag here. Rest all remains same, there is no change. Even I'm not changing the port because I wanted to show you something. Let me execute this command. So docker daemon initiated the process and it tried to find the image locally, but as you can see the message, it is saying unable to locate, unable to file the image which you are calling locally. That's why it is initiating docker pull from docker this repository which is defined here. You can see we just executed docker run command, but just because it did not find the image locally, it initiated docker pull operations on behalf of the docker run command that was executed by the docker admin. It is pulling. I'll pause the video until the pull or download is completed. Here we are. Download is completed, but we also got an error here. This I was aware that we are going to get error. The reason is, you can see error response daemon driver failed programming externally connectivity, because we did not change the port number of the container that we are going to publish as in service outside, because we used the same port to publish our previous container also. That's why this creation got failed. Docker requires whatever containers that we are publishing as a service outside, Docker require all the services, all the containers to be published using unique port defined as a node port here. That's why we are seeing two port numbers here. This is the port that node is going to listen, and this is the port that container is listening on. Just because we use the same port for our Ubuntu system and we define the same port for web system also, however this was not correct, but I just did it to show you the difference. Whenever you are executing any docker run command, you are trying to run a container using any container image, make sure if you are publishing any service, your node port should be unique and identical to that particular container. Now let's do one thing. I will not make any other change. I will simply correct these port numbers. My container was listening on port 80, and then I will publish, let's say on node I will be using port 8080, and inside the container I am using port 80. I can use port 80 directly here also, because at present port 80 service is not running for any other container or any other process on this particular node. I'll hit enter. We got another error. Now let's correct it. The reason is because when we executed the command for the first time, Docker created the container, but it failed to run it because of the conflicting port number. And if we are doing the same, if we are giving the same name again, then the name is conflicts. So Docker requires the unique node port for each container service that we want to publish, and Docker also requires all the containers that we are creating to have a unique name also. Let's perform a docker container ls command to see that at present we have only one container running, but if you use all, you will find there are two containers which got created. One was named at Ubuntu sys1, which is running as in up state because the port numbers and all the parameters and values that we had given during the with the commands were correct, and that's why this container is running successfully. On the other side, we provided invalid or duplicate port information for the websys container that we were created. You can see container status got created, but it is not running because of the conflicting error that we got. As you can see, the name of the container is websys1. That's why we were not able to run the same command again, and it was failing. Let me rerun and show you. This is saying already use websys1, which is the name that we are giving. The container name websys1 is already in use by container ID, this one. What we can do is we can solve this problem in two ways. Either we change the name of the container, or we delete the container that is in failed state and in not running states. So let's do that. Let's delete the container and rerun this one. So to delete the container, the command is docker rm and then container ID. So container got deleted. If I'll run container lsa command, we will see only one container, which is Ubuntu sys1. Now let's try to execute the same command without making any change to the command. Let's see whether it is working or not. You can see the container got created, we got container ID here, and if I'll run container image ls command, docker container ls-a command, we can see both the containers are running, and then we can see this by normal command also. So we can see the Ubuntu system is running and listening on port 2022 as a node port, and then it is forwarding the traffic to the container port on port 22. And then similarly the same is applicable for the websys1. It is my node is listening on port 80, and then it is forwarding the request to the containers port 80 internally. So my both the containers are running, my both the images are locally stored in my local system. Now let's do one thing. Let's try to access the services from outside the container to further understand what is running inside the container, whether the container is actually functional or not. So to access it, what we need to do is we need to find the IP address of the node, which is 105. Let me show you. Here it is. And we can access it. Let's say we need to access the service. Simply copy this and enter it. You can see the container, the web page that we had created while creating the containers. You can see we got the response, hello, I am a container inside a KTS pod running HTTP page 1. So this is the message that we had given, if you remember correctly. And then now let's try to do one more thing. Let's try to access the container Ubuntu sys1 from the outside the prod node or container docker node that we had created. Again, we'll use our putty for this function, and I'll give the same node port IP because this is the node on which this container is running, and then this is the node port that we had given while running the containers. If you forget the node port, you can simply use docker container ls command to find the node port. You can see here the same thing we are going to do. We will be giving this thing, and that's all, except It is asking for username. We had given test as an username and test as an password also in the Docker file that we had created for Ubuntu sys. We are inside the Ubuntu sys container. You can see here, right? You can perform any function, any operation, whatever you want to do, you can do it here. We are in both the containers are running. We are able to access both the services from outside the Docker node successfully without any problem. That's all in this section, and in this section we understood about how to perform Docker pull operation to pull the images from Docker Hub repositories, and then we perform Docker run operation to run a container for the image that is locally stored, and then we perform another command to run the container for the image that is not locally stored, so that we can see the difference how it is going to invoke the Docker pull operation on behalf of Docker run operations. That is, we have also seen successfully. Then we created two containers, one is for Ubuntu sys 1 and the other one is for web sys 1, and then we tried to access it from the outside the Docker node. That's all for the day. Hope you enjoyed watching. If you find it useful, please encourage us with your comments, likes, shares and subscriptions. Thanks for joining. Stay tuned for more videos.